Thank you for this opportunity to present the results of my research. My report is entitled Formation of Austenite Particles Enriched in Manganese up to 20 atomic percent and more in volume of iron and 6.35 atomic percent of manganese alloy in temperature range from 300 to 450 degrees Celsius during irradiation with argon plus 15 kiloelectron volt science. In our lab of the beam actions in the Institute of Electrophysics, we carry out the fundamental and applied studies of the gas ion beam from 10 to 50 kiloelectron volts energies effect on metals and alloys. My colleagues developed methods of modifying submillimeter and millimeter surface layers with this ions beam, and we can to make different phases or different properties of these layers in metals and alloys. The previous research was about the ion beam modification of the iron and 6.35 atomic percent of manganese alloy using the argon plus ions with an energy of 15 kiloelectron volts. The purpose of my research is to confirm and complete the results of the previous research, and and the formation of the gamma phase, the FCC lattice, with the low concentration of manganese alloy using ion beam for a short time and low temperatures. I should be noticed that nobody never give the gamma phase in this low concentration manganese iron alloy using the low temperatures below 400 degrees Celsius and for a short time, for several seconds. There are some research about this method, but not using thermal processes or ion irradiation. They use the megaplastic deformation, and also my purpose was to construct the low temperature area of the equilibrium phase diagram of the system iron manganese. The material of my research was the cold deformed metastable iron and 6.35 atomic percent of manganese alloy. The thickness of my samples was 25 micrometers for the Bauer analysis, and the main method of impact was the ion implantation, island 1 implanter with the source with hollow cathode and low pressure. The energy of ions was 15 kiloelectron volts, and we also used the non-contact infrared heater to compare the impact of ion radiation. The main method of analysis was Bauer spectroscopy, and the second method was transmission electron microscopy. On this slide you can see the heating and cooling curves of our specimens under the action of iron irradiation and the infrared heating. Blue, red and black curves are different temperatures of impact. The infrared heater has the same power density as ion beam. Now a few words about the method of Mies-Bauer analysis. You can see the Mies-Bauer's spectrum with 3 Zeeman sextets of lines, first, second, and third one, and the one singlet in the center of this spectrum. We can calculate the areas of the area of each sextet and the area of gamma phase. Singlet is it means that there is a gamma phase in this alley, and when we calculate these areas, we can compute the concentration of iron 57 in the gamma phase and this iron in the alpha phase. The areas ratio is equal the probability ratio. We can to calculate the probability ratio, and the next step is to calculate the alpha, the short range parameter order by Color-Warren. It is from 0 to 1, when 0 is the absolutely ordered, and 1 is it means that the alloy is absolutely dissolved. When we calculate these concentrations, we can to compute the concentration of manganese in the alpha phase and the concentration of manganese in the gamma phase using these simple equations. Now let's talk about our data. There are the initial spectrum of the spectrum of initial sample, and 3 spectra of the heated specimens up to different temperatures. There is no singlet in the center of the spectra. It means that there is no gamma phase or FCC lattice in this cell. And we calculated alpha parameter. It's equal 0 for each one, for each spectrum. On this slide, you can see three spectra of irradiated samples. There were singlets on this spectrum, and we can say that there is gamma phase in the irradiated specimens. The isomeric shift of this singlet is the isomeric shift of the gamma phase minus 0.08. Then we calculated the concentrations of manganese in alpha and gamma phases, and now we can note it in the equilibrium phase diagram of iron-manganese system. As you can see, these points of concentration of the manganese in alpha phase and concentration of the manganese in gamma phase is closer to the extrapolation lines of the low temperature region of this diagram. It should be noticed that these lines in the high temperature area is an experimental lines, and these lines are the extrapolated lines. And we confirmed our results of Miss-Bauer analysis using the transmission electron microscopy. You can see this cellular structure of the initial sample, of the initial specimen cold deformed, and it is normal for cold deformed state. There are the Bragg's reflections of BCC lattice of the alpha phase in this specimen. And look at the next slide. They are the patterns of transmission electronic microscopy for the specimen after ion irradiation up to 311 degrees Celsius for only 4 seconds, and you can see the same structure, and also you can see these fragments of the FCC lattice of the gamma phase, and there were BCC and FCC Bragg's reflections. To conclusion, I'd like to say about that we use the ion irradiation to get the alpha phase to form in our alloy, and it was low temperature and short time ion irradiation. Also, we construct the low temperature area of the iron manganese phase diagram, and we confirmed our Miss-Bauer's analysis results using the electron microscopy. And this method is the good method for achieving equilibrium states of always at subnormal temperatures for a short time. Thank you for your attention.